Hello everyone, welcome to my channel. Today we will be talking about odd and even functions. So first of all, what is an odd or even function? Okay, so the definition is this. If it's an even function, it's going to be f of x, let's say that was the original one, equals to f of negative x. A good example of this function, which is easy to understand, is x squared. X squared, let that to be f of x. So f of negative x is going to be equal to negative x squared. But since it's a squared term, the negative sign gets canceled out. So that becomes x squared, which is the same as the original one. So that's an even function. So now we will be talking about odd functions. So the odd function is like this. So let's say f of x is the beginning one, but it's a little different. It has f of negative x equals to negative f of x. Another good example of this would be x cubed. If we plug in negative x and cube it, since the exponent is odd, then it'll be negative x cubed. And if we negate the original function x cubed, we still have negative x cubed, which is equal. So x cubed is an odd function. Okay. So after this, let's give you some extra tips for this. So a really good hack is for even functions. You can try to do this, but sometimes it doesn't work. But all the exponents are odd. Sorry, they're all even. My bad. This really helps because, as you can see, in x squared, the exponent 2 is even. And for odd, it's kind of the opposite. All the exponents are odd. Another really good hack is for even functions. For example, x squared, they're symmetric about the y-axis. Oops, sorry. It's not a really good diagram, but kind of get the idea. X squared is symmetric about the y-axis, while x cubed is symmetric about the origin. So, the even functions are even exponents and symmetric about the y-axis, and the odd functions are odd exponents and symmetric about the origin. Okay, so now let's go through some basic problems. So before we continue, let me first just put the basic fundamentals in the top right corner so that we can access them easier. So the even function and the odd function. Okay, so now let's go to our next problem. We'll try to figure out if x cubed minus 2x is even or odd. As a little hack I mentioned earlier, all the exponents are odd. So like the exponent 2x is 1. So since the exponents are odd, this function f of x is odd. Okay, so now let's get to a little challenging problem. So let's say f of x equals to square root of x minus 1 plus square root of 1 minus x. So this looks really unique because like there are square roots and like x minus 1 and 1 minus x. But it kind of like, it's a little abstract, but it's not that hard. As you can see, according to our square root inequality, we have the inside, which is x minus 1, to be greater or equal than to 0. So therefore, after adding 1 to both sides, we have x is greater or equal than to 1. And meanwhile, since this also has to be greater or equal than to 0, then 1 is greater or equal than to x. And these look very like familiar, but you can see that x needs to be greater or equal than to 1, but 1 is also greater or equal than to x. So if you think about this, x has to equal to 1 and 1 only. Like not 1 and 1/2 or like half, or it's strictly 1. So you can graph this to see if it's even or odd. So as you can see, x is 1 only and y 0, so it has to be this point right here. And according to our hack, like this is not even because it's not symmetric about the y-axis, and this is not odd because it's not symmetric about the origin. So I guess this isn't either of them. And yeah. Okay. Let's do another one. Let me see. Okay, I got a slightly similar one. Let's say that f of x equals to x squared minus 1, the square root of x squared minus 1, plus the square root of 1 minus x squared. And according to the previous one that we did, x squared is equal to 1. So that means that x equals to 1, right? Well, no. Because x can also be equal to -1. Negative times negative is positive. So x is plus or minus 1. And that's really different than the one we just did. Because this one had x equals to 1 only. This one has plus or minus 1. So this time, if we graph it, we'll have -1, 0, and 1, 0. And this, it turns out, is symmetrical across the y-axis. So this is even. Let's check if it's odd. So it's kind of weird to have it be symmetric about the origin, but I think this works because like its axis, like like you can just flip it about the origin and it also works. So apparently this function is both odd and even, and that's very rare. Okay, so now let's do a slightly different type of problem, but it's all orientated about odd and even functions. Whoops. Okay. First erase this. Okay, so let's do this type of question. Let's say that f of x is odd and g of x is even. And let's have the sum equal to x to the power of 5 plus x to the power of 4 plus 1 over x. As you can see, it's sort of obvious that f of x is just x to the 5th plus 1 over x. Because you can see that 1 over x equals to x to the power of -1. And that is an odd exponent. X to the power of 5. 5 is an odd exponent too. So f of x is x to the power of 5 and 1 over x. And coincidentally, g of x is the only term left, which is x to the power of 4. And since 4 is even, then g of x is even, and that satisfies the desire. Okay, but these types of problems can get a little tricky. Okay, so let's make this a little harder. Let's say that f of x is odd, g of x is even, but this time f of x plus g of x equals to 3 to the power of x. And you can see at 3 to the power of x is the exponent, so it's not even or odd. Well, it kind of depends on x, so it's not really one or the other. Okay, so this trick involves the little index that we left in the top right corner. And this time it really helps because now we can plug in -x into the function. So that's basically the whole point. So plug in -x. This makes it f of -x plus g of -x equals to 3 to the -x. Remember, the exponent is still x, so we have to make it negative. And you can see that f of x, f of -x equals to negative f of x, because f of x is odd. And plus g of x, because g of -x equals to g of x, according to the even function. And that is still equal to 3 to -x. So we only change the left-hand side. And as you can see, these two equations are equivalent. So basically this is a linear equation, so we can try to add these two up. So since this is f of x and this is negative f of x, the f of x gets canceled. So we're left with 2 times g of x equals to 3 to x plus 3 to negative x. This leaves us with g of x equals to 3 of x, 3 to the power of x plus 3 to the power of negative x over 2. So that's what we get for g of x. And to figure out f of x, it's pretty easy. We just plug it into the equations, and we can see that f of x equals to, if we plug it into the first equation, it becomes 2 times 3 to x, and then minus it. Okay, so it's going to be 3 to the x minus 3 to the negative x over 2. Let's see if that works. The negative x gets canceled out. And yeah, it works. So these are our final answers. These are a little more tricky than just finding it obvious, because these actually involve like the sum to be very unique, and sometimes it's not that obvious. So the main takeaway is to plug in negative x. And I think that's all that we have for today. So if you enjoyed this video or found it helpful, please consider subscribing to my channel. So bye! See you in the next one.